Problem 18, yeah. Alright, this problem is using a little bit of calculus, going from velocity to acceleration, but it's also using the notation for two-dimensional motion, or basically physics in two dimensions, where you have x equals I hat, y equals j hat, and if there was a third dimension, that would bring in k hat. That was stuff we did in the last chapter, right? And vectors. So this problem gives us a velocity function. endless. That's right, I totally forgot that. Every time I record a video, the first time I try to write, the pen doesn't even need to touch. See right now, I'm moving and no ink because I'm hovering above the tablet. I have to actually touch the tablet to get ink. But for some reason, the first time I start recording, it anyway, whatever. So this problem gives us a velocity function v equals 6t minus 4t squared, and this is in the x direction, or I hat, plus 8, and that's it in the y direction, that's j hat. So, and this is all in meters per second. Part A asks us, what's the acceleration? Well, we've learned already back in chapter 2 that acceleration is the derivative of velocity. So we just got to derivative this with respect to t. This is t to the 1 power, so you multiply 1, it becomes t to the 0, so this is really just 6 minus, bring the 2 down, 8t, and this is in the I, or the x direction. The derivative of a constant, luckily, or nicely enough, is 0. So then it asks us for actually at 3 seconds, so a of 3. That's 6 minus 8 times 3 in the x direction, plus 0. And that equals negative 18, actually, meters per second squared in the x direction. So pretty straightforward. Part B asks, is there ever a moment when the acceleration is 0? So we'll just take this function and set it equal to 0 and find out. 6 minus 8t, and solve for t, you get t equals 3/4 of a second. So yeah, there actually is a time where the acceleration is 0. What about part C? Is velocity ever 0? C. So we'll set the velocity function, this guy here, equal to 0. 0 equals 6t minus 4t squared I hat plus 8 j hat. So definitely, actually I haven't solved it yet because of the y direction, but it looks like in the x direction there would be a moment when the velocity is 0. But take a look at the y direction. There's never a moment. At all moments, the velocity in the y direction is always 8. It does not depend on the time. So the answer is no, because there's always motion with a speed of 8 meters per second in the y direction. Part D. When, if ever, does the speed equal 10? Well, speed, we want to be careful, is the magnitude of velocity. Remember, velocity is a vector, and it has a magnitude and a direction. These show the direction, but if we want to find like the overall speed, we have to Pythagorize this. One way of writing that is you could say speed is the square root of Vx squared plus, excuse me, whoa, plus Vy squared. Hope I didn't just put you all to sleep. And so we just plug in the x component here and the y component here, and this becomes 6t minus 4t squared, all squared, plus 8 squared. And we want to know, is this ever, can this ever equal 10? What time is it equal 10? So the easiest thing to do is square both sides. The square cancels the square root. So you get 6t minus 4t squared plus, let's just square this, 64 equals 10 squared is 100. And do a little bit of algebra. Maybe I'll do it over here. Doop, doop. So the next step, I'm going to subtract 64 from both sides. So it gives us 6t minus 4t squared, all squared, equals 36. Square root both sides. We get 6t minus 4t squared equals, now tricky thing, we'll want to call this plus or minus 6. I'm sure you've seen this at some point in your math careers. 6 squared gives us 36, but negative 6 squared also gives us 36, positive 36, because negative times a negative is a positive. So this could be either plus or minus, and that's going to matter because if we solve this for 0, minus 4t squared plus or minus 6 equals 0, we're going to find that if we use plus, no roots. So we want to do the minus. And that's also, while we're doing that, divide by 2. So this becomes 3t minus 2t squared, and then again the plus one doesn't have any solutions, so let's do the minus 3. 0 divided by 2 is 0, so that stays 0. And this has roots. We want the positive one, and that happens to be 2.19 seconds. And that's it for problem 18. So pretty straightforward. This problem was showing us, allowing us to review a bit what we learned in chapter 3 with vector notation, I, J, K, etc. Also what we learned in chapter 2 with the relationship between velocity and acceleration, and also what we're learning now with, and we learned in chapter 2 as well, speed is the magnitude of velocity, and but just basically moving it into 2 dimensions. So really the only new thing, I guess, is probably this Pythagorean, but I think that was also in chapter 3 as well. Yeah, chapter 3. Yep, to find the magnitude. Cool. Alright, so the next problem is problem 24, and that's from projectile motion. That's sort of the heart of this chapter. So I'll see you then.